So those were some examples I had come up with in my differential equations course. Here is one of my heroes in the work of math education, Tom Paff from Ithaca College. And he has created quite a number of modules relating sustainability to math, to calculus, and also statistics that one can just plug in to math courses. So we'll talk a bit about this idea of these ready-made modules. I'll share one that I've created based on Tom's model at Bryn Mawr College where I teach. Here we see off in the distance a small solar array that we have on our campus. How many of you have solar arrays on your campuses? You might want to take a pause now with your groups and talk a little bit about what do you know about solar power and solar cells, photovoltaic solar energy. So let's take a pause and you can have a little discussion in your group. Here let me backtrack a bit to our educational theory. One reason I have you doing this discussion about solar energy is because I want you to bring out of long-term memory what you know about the issue of solar energy. And then once it's out of long-term memory, it's ready to be accessed so we can connect this pre-existing knowledge you have to the new knowledge we're about to do on the math of solar energy. And also, as you discuss, I can go around and listen to you and find out what misconceptions you might have about solar energy that I might want to try to address during our lesson. So we're going to see a lesson on solar energy, but before we do, we're going to take a field trip and we're going to walk across campus to the solar panels and take a look at them and talk about solar energy. So I did this as an optional outside of class event, and about a third of my class showed up and we walked over to visit these solar panels on our campus. Well, these solar panels are connected to a website where we record the power that these solar panels generate. And here we see several days, 1, 2, 3, 4, 5, 6, 7 days way back in January 2014. And here we have beautiful graphs. As a math teacher, I always love having graphs and data. And a question for you and your group is, why do these graphs look different on different days and at different points in the day? So discuss that for a moment. So as your group probably decided, the weather was different on those days. On a cloudy day, you'd have very little solar power being generated. On a sunny day, much more. And as the day went on, you might have moments of cloudiness and then others where the sun is shining brightly. So this is the power produced at different times of the day in units of watts. If you think of a light bulb, a 100-watt light bulb, which is kind of a former standard being kind of changed now as we have new compact fluorescent or LED bulbs. But the rating of 100 watts means that each instant the bulb is using 100 watts. More technically, a watt is a joule per second, so power is a rate of energy use. So during the day, your solar panels are producing this amount of power. And if you add up the total energy produced in the whole day, you get another set of graphs. So again, as a mathematician, this is wonderful. Here we have graphs. So this gets to my point about certain aspects of sustainability. You cannot study them without using mathematics. If you're looking at energy use, energy production, you're generating graphs, and graphs and data are mathematics to be analyzed. So the problem I want to focus on is, given one of these power graphs, here we have one from January 17th, how much energy is produced over the course of the given day? So more generally, what's the relation between the power graph and the energy being produced? So here we have a handout that you can work on with your group where you explore for yourselves the units of power, which is the watt, the unit of energy. You can use the electric bill that comes in the packet to see the units of energy. And then what is the connection between energy and power? So pause the video now and work through some of this sample lesson. Okay. So let's come back together again. If you looked at the bill, you saw that the unit of energy is kWh, which stands for kilowatt hours. So we talked of the 100-watt light bulb. If we have 10 of those bulbs going together, that uses 1,000 watts. That's 1 kilowatt. And then if we had those 10 light bulbs running for 3 hours, the energy we would use would be 1 kilowatt times 3 hours. So that's 3 kilowatt hours. We get this new unit of energy, which is the kilowatt times the hour, 3 kilowatt hours. And in your worksheet, you notice that you can represent the area under this little problem of the fixed power times the time as the area in a rectangle. Or in a more complicated example, it's the area in several different rectangles. So here we see the very important idea that a physical concept can be the area under a graph. And if we go back now to our more complicated power graph, the extension from our simple examples of power and energy is that the energy produced over the course of the day is the area under this graph. And if you've had calculus, you know that the area under a graph is one of the key concepts of calculus. It's the notion of the integral. And so here we have a real-world problem of an important type, solar energy, that leads us to need to calculate an integral. Partly I was motivated in making this problem by overhearing a few students in the gym at my college. And they were talking of their math lesson that day where the professor spent a lot of time talking about a really complicated thing called Riemann sums, which is adding up little boxes, and you take more and more boxes, and you take a limit of the number of boxes going to infinity, and you find out what the limit of the area is produced by these boxes. And the student said, and this was really annoying because at the end of the lesson, the professor said, but all this stuff with the boxes is equivalent to taking the antiderivative. Well, why didn't he say so at the beginning? Why did we have to spend all that time doing this complicated Riemann sum? Why didn't we just do the antiderivative from the get-go? Well, I would hope in this lesson on power and energy, we do not have a formula for this curve. All we have is a set of data points which we can keep in a spreadsheet, for example, and the power is given by that data, not by a formula. So we don't know how to take an antiderivative because we don't have a function or a formula. So we really have to add up boxes to find the area under the curve. We think that on a very short time interval, the power is about constant. So we can approximate this curve by a bunch of short horizontal lines and then find the area under all those lines. So not only can sustainability illustrate an important idea of calculus, the integral, but it can actually force students to think about it in a deeper way, where they confront the fact that integrals have to deal with real-world data that are not given by formula, and so they need to really understand the notion of a Riemann sum, which leads into the idea of numerical integration with, for example, the Euler method or the trapezoid method or the Runge-Kutta method. Numerical integration with Riemann sums using boxes, using trapezoids, the more complicated Simpson's method. So this one example can link into a lot of material in the course about mathematics of calculus. And then I try to end this unit with a big question. Do you think it's worthwhile for your college to get solar panels? Would it be worthwhile for your home or your community to have solar panels? So making a connection problem, linking the mathematics back to a real world example. And one could, if one wanted to, have the students research that. I'll talk a little bit later about service learning projects where they do these things more extensively. But one could just make a simple question and have them write a paragraph. One could also ask them, what kinds of questions would you ask and what information would you need to gather to be able to answer this question of whether it's worthwhile to get solar panels. And that lays a good groundwork for the whole issue of mathematical modeling and how do you use math to answer a real world problem. Okay. Beyond using these sustainability units in differential equations and calculus, I've also used them in courses on math modeling. I've developed a course called Math Modeling and Sustainability, and then a version of that course is our senior seminar for our advanced students. And here are some of the resources I use in the course. A beautiful book called Math Modeling in the Environment by Charles Hadlock, some of the sustainability units by Tom Paff. In the Hadlock book, there's a nice chapter on groundwater flow that leads into the Laplace equation. We look at solar energy, we look at wind energy, we look at energy in houses and insulation and how that can conserve energy. Also the leakage around windows and doors, how does that affect energy use? And in these courses, I have the students do a service learning project in partnership with the community. And as I've gotten more involved in this idea of math modeling and sustainability, it's led me in new directions. I became the chairman of our college's sustainability committee. I've now become the director of our environmental studies program. So a little word of warning as you begin linking your math or science teaching to issues of civic engagement, it could lead you in exciting, new, but very different directions. So Bryn Mawr has joined the President's Climate Commitment program, and now we're also in the ASHE program, where we're trying to reduce our carbon footprint. So that gives me the opportunity of linking the student service learning projects to actual issues that the campus is facing. Another great resource for the course is a book, Sustainable Energy Without the Hot Air, by David McKay. It's available free online, and it uses, in many cases, just high school algebra, but in very clever ways to model the issue of sustainable energy and is it possible actually to scale up from small levels of renewable energy, wind and solar, to large scale renewable energy that could power our entire nation. So let me talk a little bit about the service learning projects that I have the students do in conjunction with the classroom work. And as I look back over the projects the students have done, they fall into a couple classes. One is the issue of waste, another is energy. And in these projects, we work with a community partner, but we've broadened the notion of who a community partner is to include our own institution as being part of the community. And so quite a few of these projects, the community partner was staff members in the facilities department. These people are very knowledgeable about issues related to sustainability in the environment, and they're very eager to be involved in the educational enterprise of the institution. Many of them, one of the benefits and joys of working at a college institution is getting the chance to interact with students around projects of this nature and playing a role in the educational enterprise. And so many of these partners have been the staff who supervise and guide the students on these projects. The first project I mentioned is the trays in the dining hall, and it was the question of whether we should stop using trays. Would that cut down on food waste, and would that save money in terms of washing costs? And what the students found out is it would save food waste. They did a weighing when they had trays, and then one day when there were not trays. And then they also estimated it costs about 5 cents to wash a tray when you take into account the cost of the hot water, the cleaning supplies needed, and also the time of the workers. And 5 cents does not sound like much, but they estimated when you count how many trays get used through the course of a year, that adds up to $38,000. And they presented their report to the dining directors, and the end result was we no longer have trays in the dining hall, that you carry your plate and you might have to go back multiple times if you want to have big helpings. Growing out of that issue, students began looking at composting, could the college compost its food? Initially, the composting company they used in a pilot project came from Wilmington, Delaware, which was about 30 miles away, and it made that 30-mile round trip 3 times a week. And so it wasn't clear that there was actually an environmental benefit to having composting if we did it with this particular company. So the students analyzed these benefits, they analyzed the cost, they found a new composting company that was much more local, and then with this new company in their analysis, there was a definite benefit to the composting, and the money we saved by reducing trash output from the dining hall would pretty much pay for the composting. So that was, again, they gave a report to the college dining services, and it led to this now widespread composting project. Growing out of the composting, this idea that there was less trash being generated, that got the facilities people thinking about, are we really using the trash bins, these big dumpsters around campus, to the full extent? Or are these trash bins only partially full? Since we pay by the pickup and by the size of the trash dumpster, if the dumpsters are not being fully utilized, maybe we could have less pickups per week, or maybe we could have smaller dumpsters, and that would save the college money. So the trays led to the examination of composting, led to a trash audit where students worked with the facilities department to measure every day, several times a day, how full the trash dumpsters were. The facilities people painted lines on the dumpsters, quarter full, half full, 3/4 full, and the students recorded how full the dumpsters were and presented their findings and a recommendation that in some cases they could reduce the size of the dumpsters and we wouldn't have any problem of overflow. That would be a very bad thing if the trash overflowed onto the ground, and so we wanted to make sure that would not happen. As a result of that project, the facilities people, when they signed the new trash contract, reduced the size of some of the dumpsters and ended up saving the college $1,000 a month. So through these projects, the students have an excellent experience of facing a real-world problem, and in many cases, they've had a real impact on our institution. I'll just briefly mention some of the other projects they've done. They worked with the local school district to analyze whether the school district should handle its trash system and recycling system with an outside company, which is how they presently did it, or would they actually save money by handling it in-house. On the energy front, students looked at whether we would save energy if we put the buildings into conservation mode. We had not really realized it until the students asked the question, can we save energy in the way we run our buildings? But they found immediately that some of the buildings were heated and cooled to kind of a comfortable temperature 24 hours a day, 7 days a week. And partly this was explained that one of the buildings was being kept in good working condition all night long in case students wanted to have meetings in this building. This was one of the buildings that students could use for midnight meetings. Well, what we immediately realized as we talked about it was, as far as we know, students have never had a meeting in that building in the middle of the night. So this idea of keeping it well heated or cooled in hot weather was just an absolute waste of energy and money. And that led to a whole review of the college policy where we realized that actually all the buildings were being heated or cooled 24 hours a day. So even before the students had done any advanced math, simply by asking these questions they came up with, they got people thinking in new ways that led down the road to changes. So over a 3-year process, the facility staff and the sustainability committee met with people in every building, discussed issues of conservation and sustainability with them, presented the findings of how much energy we could save if we reduced the temperature during the night and made sure that all the lights were turned off, and asked each building to come up with their own hours in which we would set back the temperature, what we call conservation mode. And so that big impact on the campus grew out of the student work. They looked at savings for putting LED bulbs into the lights. They looked at how much savings we could get if we put on-off switches on some of the chemistry hoods. Right now, the research hoods don't have any off switches, and so they're in use all the time, even if there are no experiments being done. And that turned out to be a significant energy savings. They worked with a local township where they were creating a new recreation center, and they wondered about putting alternative energy features in the center. They worked with a retirement community that wanted to be more sustainable, and the students analyzed energy use, particularly around light bulbs for them. So there were a wide range of projects the students did, and often the end result of one project would lay the groundwork for the next project.